Hi, I'm Corey Smith, and this is a chemistry project about batteries. This is a battery. It is a AAA battery, and it is 1.5 volts.
Alright, batteries have been around for hundreds of years. They allow us to have electricity without being plugged into the power grid. Without batteries, there would be no sustainable portable electronics. A battery is defined as a device that produces electricity through a chemical reaction called an electrochemical reaction. The term battery was first coined by Benjamin Franklin to describe an array of charged glass plates. Alessandro Volta invented the voltaic pile by stacking layers of zinc, brine-soaked cloth, and silver. This was the first practical method of generating sustained electricity. Since then, there have been countless design improvements leading to smaller and lighter batteries that can provide more electricity. Battery improvements allow mobile electronics such as laptops and cell phones to be lighter and faster. Future designs could allow cell phones to last weeks or months on a single charge and be able to fully charge within just seconds. The outside of a battery has both positive and negative terminal. Inside the battery case, there is a cathode connected to the positive terminal and an anode connected to the negative terminal. The cathode and anode are separated by and react with an electrolyte. The anode reacts to release electrons while the cathode reacts to absorb electrons. This causes the electrons to want to flow from the anode to the cathode.
Alright, I'm here to explain to you the chemical reactions that go on inside batteries. The first reaction is an oxidation reaction, or a reaction where an electron is given up by the reactants. During this reaction, the electron is given up and it flows through the wire and performs whatever function the battery is set up to do. And then, while this is happening, the cation formed, or the positive ion formed, it flows through the electrolyte and goes into the cathode. After the electron has performed its function, it follows through into the cathode and reacts with the cation that was sent by the electrolyte. Then after the cation reacts, it forms a neutral atom. Then this process is reversed when the battery is recharging. And that pretty much does it for the reactions that go on inside of batteries.
Oh, dear.
This is a lithium-ion battery. It's a common battery used in phones and laptops because it's lightweight and has high capacity. The first reactions that start in the anode. It's called an oxidation reaction, where you have lithium cobalt oxide that breaks apart into cobalt oxide, lithium, and this lithium is a cation, meaning it has a positive charge, and then one electron. The electron goes through the wire and ends up over here in the cathode. And then the lithium goes through the electrolyte, or the battery acid, and ends up in the cathode as well. Then when they get here, they react with carbon. And you get lithium carbide.
Batteries allow our society to remain mobile. Lithium-ion batteries are relatively new and are used to power laptops and smartphones. If there were no batteries, there would be no portable electronics. Phone calls would have to be made with landline phones. Common battery-powered items, including iPods, TV remotes, and garage door openers, all benefit from the new and improved battery designs. Current rechargeable batteries have a maximum number of recharge cycles of a few hundred. The recharge process becomes less efficient over time, resulting in a lower capacity battery. Future batteries will be able to recharge as many as a few thousand times. Most batteries can be either high current or high capacity. For example, power cells have massive amounts of power, but can't produce many watts. Supercapacitors release huge amounts of power, but can only last a couple seconds. Laptops need both high capacity and high power. Future batteries will improve both aspects in addition to making them lighter. This will lead to electric cars with much higher range. Lithium-ion batteries are the current solution. Instead of lithium-ion batteries, the anode and cathode are almost two-dimensional. The University of Illinois has designed a new type of lithium-ion battery. It uses a three-dimensional porous anode and cathode. This huge increase in surface area allows for more reactions in a given space. Other new designs include lithium-ion batteries and sodium-ion batteries. Both are significantly lighter even than lithium-ion batteries. Having a low-weight battery is important for electric cars. Current lithium-ion batteries have a capacity of around 200 watt-hours per kilogram, while lithium-ion batteries could reach as much as 3,460 watt-hours per kilogram. However, lithium-ion batteries are incredibly hard to make. On the other hand, sodium-ion batteries are a little bit easier to make, but can only hold 1,600 watt-hours per kilogram.